Welcome to our deep dive. Today, we're going to journey to the very heart of your computer to find the one component that does all the real heavy lifting. You know, the part that actually thinks. I mean, when you click a mouse, or type on your keyboard, or fire up a game, it all just kind of feels like magic, right? Well, I'm here to tell you, it's not. To really get it, we've got to go deep inside the processor and find the special little component that's doing all the work. Okay, let's dive right in. To find what we're looking for, we have to start with the computer's brain, the central processing unit, or the CPU. But here's the thing. This brain isn't just one single thing. It's actually a team. That's right. The CPU isn't some lone genius working by itself. It's much more like a small, super efficient company with two key departments working together perfectly. So you've got one part, called the control unit, that acts as the director. It reads the instructions from your programs and basically figures out what needs to get done. It gives all the orders. And then you've got the other part, our star for today, the one that actually does all the work. So let's finally meet this doer. Its official name is the Arithmetic Logic Unit, or, ALU for short, and that name pretty much tells you everything you need to know about its two main jobs. So the ALU is really the fundamental building block here. It's a digital circuit that does all the raw calculations and makes all the simple logical decisions that your computer needs to function. Everything from adding two numbers together to figuring out if one thing is bigger than another. And this is the key relationship to understand. The control unit is the manager, right? It's pointing and saying, hey, add these two numbers or compare these two things. The ALU is the high-speed engine that just instantly takes those orders and gets it done. No questions asked. So let's look at the first part of its job, and it's the most straightforward one, the arithmetic. This is the A in ALU, and yeah, it's pretty much exactly what it sounds like. Just like the calculator on your phone, the ALU handles all the basic math. It's just insanely fast and unbelievably accurate. This is the foundation for everything from a simple spreadsheet to rendering those beautiful, complex 3D graphics in a video game. Now this is the ALU's real superpower. It can take a huge, complicated math problem and, in an instant, just shatter it into thousands or even millions of tiny, simple binary steps that it can knock out one by one at lightning speed. It's this divide and conquer strategy that gives computers their incredible power. But just doing math is only half the story. Now we get to the really cool part, the L in ALU, which stands for logic. This is what turns a computer from a simple calculator into a genuine decision-making machine. So how does it do it? Well, at its very core, the ALU's logic is built on millions of microscopic little electronic switches. These are arranged into circuits we call logic gates. And these simple gates are the building blocks that let the ALU make really complex decisions based on just a few simple rules. And honestly, it's surprisingly simple. Take an AND gate. It will only give you a 1, which you can think of as true, if both of its inputs are also 1. An OR gate, on the other hand, will give you a 1 if either of its inputs is a 1. It sounds basic, right? But when you combine millions of these simple yes or no gates, you can make incredibly complex decisions. And it's not just about those simple gates. The ALU has a whole bag of tricks. It's constantly comparing numbers to see if they're equal or if one is greater than the other. It also handles things like bitwise operations and bit shifting, which is basically just a fancy way of saying it can directly mess with the individual ones and zeros that make up all the data in your computer. Okay, so we've met the parts, right? We've got the math whiz and the logical decision maker. So now let's put it all together and see how the ALU actually fits into the computer's workflow, moment by moment. This 4-step process is basically the heartbeat of your computer. It never stops. First, an instruction comes in from the control unit. Next, the data it needs is grabbed from these super fast memory spots called registers. Third, the ALU does its thing, the math or the logic, and finally, the answer gets stored right back in a register ready for whatever's next. And when I say this is the heartbeat, I mean it's fast. It's so fast, it's almost impossible to wrap your head around. A modern ALU can run through that entire cycle billions of times, every single second. It's just a mind-boggling speed that lets us have the smooth, instant experience we expect from our tech. So at the end of the day, every single thing you do on a computer, from opening an app to editing a photo to playing a game, it all just boils down to the control unit sending billions of simple little requests to this tiny, tireless calculator and decision maker. So what's the big takeaway here? It's that the ALU is the fundamental engine that makes all of our digital innovation possible. Every leap forward in software, in AI, in graphics, it's all powered by this little thing's ability to just crunch numbers and make logical choices at unbelievable speeds. Which really leaves us with just one question. What are we going to ask this incredible engine to build for us next?